Hello, ladies and gentlemen, it's Mr. Green again. This is another in the series of Algebra 2 lessons where we're talking about system of equations. Well, we did system of equations last time. This time we're going to do application of linear systems. What? Oh my gosh, Mr. Green. I thought we were just doing that for the purposes of being mathy. No, there's actually an application of this. Not just one, but lots of different applications of using system of equations, linear equations. Here's an example. If you see a word problem, and you're going to get several of them in this particular lesson, you're going to be looking at rates. You multiply the rate times the time, and rate 2 times the time, and you get the whole job. So if I've got, at the beginning of a job, they worked at this many pages per minute. At the end of a job, they worked this many pages per minute, and they worked 10 minutes in the first half of the job and 10 minutes in the second half of the job. Well, you get the whole job by doing that, don't you? And you can actually come up with a system of equations. Same thing. Here's one for distance. Here's one for total percent mix times total amount. And then the mix total times the total amount. Different ways of looking at word problems and trying to get them into a system of equations. Okay? Here's an example. Linda invested $4,000 into separating it into two mutual funds. Well, you know what it told me right away? She had two mutual funds, X and Y. Pointer. X and Y. You add those together, it's going to be equal to $4,000. X is the amount she invested in one group and one mutual fund. Y is the amount she invested in the other. First sentence, one equation. The percent return on the Star Spangled Corporation at the end of a year was 5%. I'm going to use that 5% times X. I just know I am, okay? And the percent on Dow's industry was 7%. 7 times Y. And the combined return on both of them was $256. If I add them together, I get $256. I have a system of equations. And just like we did last time, we can use our handy dandy calculator to solve these because now I've got a system of equations I can solve using the matrix math. Remember doing this? Second, matrix, right? And we're going to go in here and we're going to change. Oh, I didn't do it. Sorry. Try again. Second, matrix, we're going to go over to edit. And hit on number 1, we're going to make it a 2 by 2. That's the way the animals go into the zoo. And the first ones are going to be 1 and 1 because x plus y is 1 plus 1. And then b, we're going to say 0.05. And we're going to say 0.07 because those are the two percentage rates. Enter. Second, quit. Second, matrix. And we're going to go over to edit and to b. And it's a 2 by 1. And the values that we have here are, move the calculator over so I can see them. Oop, not stretch the calculator out, move the calculator over. Thank you very much. $4,000 was the first one. And the second one was $256. Enter. And I'm going to press second quit, second matrix, A inverse times second matrix B, hit enter, and it's going to tell me that she invested 1,200 in X and 2,800 in Y. See how the calculator helped us solve that? Real type problems, okay? So X was 1,200 and Y equaled 2,800. Well, we can check our answer real quickly here. 1,200 plus 2,800, that's $4,000. That worked out. We can multiply 12,000 times 0.05, and that's going to be $60. And we can multiply 7 times 2,800, and that's going to be $206. And guess what? It worked out just beautifully. Okay? Let's go look at some more. Certain brand of orange juice has 16.7% of the recommended daily allowance of vitamin C per ounce. Wow. The same brand of pineapple has a 5.5 RDA of the vitamin C per ounce. Okay? An 8-ounce mixture of these juices contains 120% of the RDA of the vitamin C. How much orange juice must each pineapple, how much orange juice and how much pineapple juice are in the mixture? Well, you know what? Couple of easy things to do. First of all, they're going to put in X amount of OJ, or we could actually use O for OJ, and we could use P for pineapple juice. And when you add those two together, they have to equal 8 ounces. So one orange plus one pineapple has to equal 8. And then we can use the percentages. 0.167 times the OJ and 0.155 no, it's 0.55, excuse me, 0.055 of the pineapple juice has to equal 1.2 of the total. I think I've got my equations, and I can now use those in my calculator. Okay? In case you didn't notice, calculator is your friend. Second, math. No, it's not second. Math. Second, matrix. Thank you. It's a 2 by 2 equation. Right? So second matrix, we go over to edit. We go into 2 by 2. First ones are 1 and 1. Okay? The next one is 0.167, 16.7. And the next one is 0.055. Enter. Okay? Second quit. Second matrix. Edit. And we're editing the B equation. Nope, I edited the A equation, didn't I? Okay, second quit, second matrix, go over to edit. We're going to edit the B equation, sorry, 2 by 1, and the values here are 120. Wait a second, the first one was 8, excuse me, 8, and the next one was 1.2. Enter. Okay? Second quit, second matrix, second matrix, clear, thank you. Second matrix, A, inverse, I'm messing up, sorry, too many things distracting me, times second matrix, B, and hit enter, and it's going to tell me that it's 6.78 grams of orange juice and 1.2 grams of pineapple juice, ounces. 6.7, excuse me, 6.785714,286 ounces of orange juice and 1.214285714 ounces of pineapple juice. Wow, Mr. Green, that worked out pretty easy. It's the way these problems are. The calculator is your friend. Grocery store sells pears for $1.99 per pound and apples for $1.49 a pound. Customer purchases 9 pounds. So A plus P, pears, equals 9. Right? And they spend a total of $15.41. How many pounds did each customer buy? Not a problem. 1.99 times the apples plus 1.49 times the pears equals 15.41. And once again, All you gotta do is key them into the calculator using the matrix math, and you'll get your answer. And you can give it in a complete sentence. The customer purchased this many pounds of apples and this many pounds of pears. Okay? Chemistry. Oh man, some of you have already had chemistry. It's a mixture problem. If they have chemistry requires a mixture of 20% hydrogen solution, so it's 0.2 is the 20%, and a 0.3 hydrogen solution, 0.3. How many liters of each solution are required to equal 4 liters? Well, they're giving you this number here, 4 liters, and 0.9 down here. Okay, well, it's going to be a 1 and a 1. Why? Those are the coefficients in front of the hydrogen numbers. Okay, enter it into the calculator and you could get your answer, and it would give you a really quick answer. Okay, I'm not going to take the time to enter them all into the calculator anymore. Mario invested 7,402 mutual fund accounts. Okay, let's see here. We're going to have account A and account B, and we're going to add those together, and they're going to be equal to 7,400. Okay? One of them earns 7.35, so 7.5 times A, and the other one gets 9% times B, and he gets a total of $636. Okay? What's wrong with this? They're percentages. That's 0.09 and 0.075. No decimal point there. Okay? I had to move it 2 units over, 2 decimal places over, because they're percentages. Right? So once I moved them 2 percentages over, that will work out and tell you exactly how much was invested in each mutual fund. Okay? So I've worked several of these problems. Make certain you go out there to the reference guide and you work several of them yourself. Make certain you understand how to work them. If you have questions, bring them to the TOGA sessions. Bring them to the sessions where I'm at, and I will help you work them, and we can get them worked out without any problems whatsoever. Okay? I'm looking forward to seeing you next time.